Hey guys, I'm Ivy. I'm a data scientist on Finastra's innovation team, and today I'm going to briefly go over how to build and implement a deep learning model and how to connect to a Finastra FusionFabric.cloud API. So in the financial industry, payments are often initiated through email, where an amount in currency is sent for transfer between a debitor and a creditor. This is a highly manual process that requires a person to parse through emails and enter the payment transfer details by hand. Here's a sneak peek of our deep learning model integrated into a Gmail extension, which allows us to automate this process. So let's get started. First, we're going to run our imports, and these are the libraries that we're going to be using. And then we're going to need to load in our data. Since we're working with unstructured data, we first need to clean it. So we perform things like removing the parentheses and fixing the punctuation. And this is what our new text looks like. Now, this is a really cool data visualization tool that we use to see the most popular words in our data set, and this is called a word cloud. So unsurprisingly, we're seeing words like transfer, account, move, dollars. Here are also some descriptive statistics around the email, such as the average length, which looks to be about 270 characters. Now that we have clean data, we extract the labels from the sentences. In order to construct our features, we first need to loop over the sentence and tag each piece with the correct part of speech and label, and this constitutes our pre-feature vector. For example, here we can see that move is tagged as a verb. Now, our machine learning model takes an input vector that represents an enumerated position of a word with its associated padding. So the target variable is a one-hot encoded vector where a 1 represents the position of the tag. So in our getFeaturesVex functions, we get our set of words and tags and create this enumeration for our input and the encoding for our output. 32 for the dimension is a fixed parameter that we chose, but this is something that you can change to see how it affects the model's results. So now we're going to go ahead and split our data into training and test sets. So as we get into the model's architecture, I just want to note that we're going to be scrolling through this notebook pretty quickly, but there's a lot of background information that we've typed up, so I recommend that if you have some spare time that you just pause the video and read the text in the background. So model architecture. Our bidirectional LSTM is a recurrent neural network, and in particular, it's a long short-term memory model. So each LSTM has 4 gates that decide which information to forget, which information to store, which information to update, and which information to output. So simply, these models have like an internal memory to process variable lengths of sequences, and so they're really good for sequential or NLP-based tasks with text data. This one is also bidirectional, which means that it reads the information from past to future and from future to past to help understand context. And then lastly, we use a conditional random field for predicting the sequences. Now, using the Keras-based TensorFlow, we start with an input layer that is the length of our feature vector, which we decided on 32 dimensions. We then add an embedding layer, a bidirectional layer, a time-distributed layer on top of that, and then we wrap our model into a conditional random field. Now to train, we chose 4 epochs and a batch size of 64, but again, these are parameters that you can alter to see how they affect your model. To evaluate the performance, we're going to look at the model's accuracy and the loss. We can see that as the number of epochs increase, the accuracy also increases and the loss decreases, which are all good things. So now we can look at the classification report where we can see the precision, the accuracy, and the F1 score. Here we wrote a quick function to format and return some of the information about the sentences we pass in for prediction. So we can see that for the given input sentence, we have exactly the correct predictions for the amount, currency, and the 2 bank accounts. So now we're going to save our model as an H5 file, and to load it back in, we need to write a little bit of custom code. So we created two functions that load the model, which help us integrate this with different applications. And now we're all done with the machine learning part. Now we're going to take this extracted information and learn how to utilize FFDC's Payment Initiation API. So first, we're going to need to authenticate. We have a CSV file called config.csv, which has the application ID, access key, the URL, token endpoint, and base URL. So below, we created a Python class that allows us to easily connect in an object-oriented manner. We're simply going to pass in our config.csv file through the class, and then when we receive a response code of 200, it means that we're authenticated and we're all good to go. Then we're going to fill in the post request with the debitor and the creditor accounts, the currency, and the instructed amount. So to help make a request to the API, we created another class, and we have our payment initiation endpoint in the base URL in our init method. We also have a connect endpoint method that will post the payload. Let's take a sample of our deep learning model's output and structure the JSON payload. We see that the dictionary holds all of the model's predictions. Okay, so now we're going to post this payload, and we just got a 200 response, which means we've made a successful post. And then we're also going to print the text in the response and copy this payment ID so that we can use it to check the payment status. So here we modified the base URL to be a payment status endpoint. This will facilitate the status of our payment when we pass in the payment resource ID. Now we're going to perform a GET request and check on the payment status. So we're going to paste this in and run it. And we can see that our payment post request was successful and that we have a pending status. Okay, so we've got the NLP model working and the API working. So we're going to take this one step further and look at an example of how we can leverage this model in an embedded application. So we created a Gmail app extension that performs the NLP on Gmail text. We're going to hit compose and type in a new email requesting a payment transfer, and once we're done typing, the model will highlight our fields automatically for us. And then we can post the extracted information right into the API by hitting this button here, which gives us a pending status, which means we're all set. Now you've seen how to build and implement a deep learning model and how we can utilize FFDC's APIs in conjunction. Thanks for watching. Bye, guys.